Hello, am I audible? Hello, am I audible? Please raise hand or like just let me know in message if I'm audible or not. Okay, let's wait till 6:10 and then we can start. I'm waiting till 6:10. After that, we will start with the doubt session. By then, let me give a quick introduction of myself. My name is Sahil Mishra, and I am doing my PhD from IIT Delhi. I'm a PMRF student. So PMRF is Prime Minister Research Fellowship. So that's why I need to basically teach and clear doubts every week for you guys. And so if like I would like other people, like four people are here, by then like you can also give your introduction to me if you want. Hi, hello. Yes, yes, Sam, you're audible. Please go ahead. Okay. Mm-hmm. Okay. So any other person who wants to just give the introduction? Whosoever wants to give their introduction, please go ahead. Okay, let's wait for 2 more minutes and then we'll start. I just want you people to stay because I think you had some queries in last week's assignment, so I'll solve those queries. There are two questions from assignment 2 have been removed, question 1 and 2, because of their answers were marked incorrect. I mean, the correct answers were there in that, but we could not change the answers as per NPTEL policy. So we have to basically discard the questions. So let's wait for 2 more minutes and then we can start. Or if you have any specific doubts, you can just shoot. Okay. I'm willing, like will be more than happy to solve them. Please go ahead. Okay, it's 6:10. Let's start. Okay, the session won't take long. It will take around 40-45 minutes. This time I'm keeping them short because then it becomes very tedious for people who are in these sessions as well. And is my screen visible? Okay. Okay, so week two, assignment two. Let's solve this one. Okay, let me just connect my iPad. I didn't expect. Like there was a single confusion in question two. Question one had some issues, but question two was a bit confusing, and that's on me because I forgot to basically. Just a second, let me project it. Screen share, screen managing. Is it visible? The iPad was visible, right? Wait. Uh, see, the iPad is visible or not? This white screen is visible? Okay. Share entire screen. And now is it visible? iPad? Yeah, the scribbler should be visible. Okay. So just let me explain question two first. Question two had a big confusion. I will just draw it. I need to make a graph. So question two had something like this graph. This is what is known as a cycle or chain graph. And what we asked if we connect alternate nodes via an edge. Okay, so what will be the new degree? So obviously the current average degree is 2. Okay, and now if you connect alternate nodes, this means n by 2 nodes are connected. So for n by 2 nodes, degree becomes 3, and for remaining n by 2 nodes, degree becomes 2. So averaging this becomes 2.5. This should have been the answer. But the thing is, if I connect this like this, if I connect like this, it's also fine. But there is also another interpretation. Say this node and this node is connected. This node and this node is connected. Okay. But see, this node and this node is not connected. Okay, and this node and this node is not connected to this node and this node, this node and this node. Okay, so every alternate node is adjacent nodes are not connected. Alternate nodes are connected with each other. Now every node has degree 4 basically. See 1, 2, 3, 4. Okay, so this also becomes an issue here. So that's why like the question was ambiguous, and that's why we didn't pursue it and we just had to drop it. Okay, so see, every node is and additional diagonal edge is added between alternate nodes. So if we add alternate like diagonal edge like this, the problem arises because there was no clear interpretation. So that's why we had to drop this question. The answer was 2.5. People somehow got 3, but it was incorrect. Answer should have been 2.5. So we had to drop this question at all. Okay. Now this one, see. So they are saying in a chain, the average degree is 1.6. Average degree formula is 2e by n is equals to 1.6, where edges is equal to node minus 1. Obviously, if there are 10 nodes, there will be 9 edges only. So this becomes 2n minus 2 upon n is equal to 1.6. Okay, if you will solve it, you will get n is equals to 5. But here it's marked wrong. It should be it is marked as n is equal to 8, which is wrong. The answer should be n is equal to 5. Got it? So this was the issue in question 1 and 2. Other questions were easy, and just let me know if you have doubts in other questions as well. I will solve them. Hello? Hello? Am I audible? I'm not audible. Hello? Now, am I audible? Okay. So what I was saying was, if you have any other doubts in week 2, just let me know. Okay. If you don't have any doubts, I will solve them. But I will also I will also be solving previous year's question as well. Okay. So just stay with me because previous year questions are very important. Because like this whole setup of all the questions, you're gonna find one of these questions in the exam. Okay, so let's go to question 3. In a weighted social graph, the centrality measure is best suited to detect weakly connected yet highly influential nodes that serve as bridges. So bridges are generally associated with between the centrality. If you have gone through the videos, you will find it. So direct question. Card centrality extends eigenvector centrality by accounting for path length attenuation. Yeah, so you will also find this there. Solving this, you can see given two users, what is their Jaccard similarity. So you can see like this has 4 nodes, this has 4 nodes. Okay, let me share my screen again. Just let me know if you have any doubts anytime in between. So user 1, user 2, just a second. Let me write it first. A, B, C, D, B, C, E, F. Okay, now is it visible now? Hello? Screen is not visible. iPad screen. Oh, sorry. I have to share it again. Share entire screen. You should be able to see this. Okay. Let me show you the question again. We are solving this question, Jaccard similarity. Okay. Let me just. Okay, so to basically solve Jaccard similarity, okay, so u1 intersection u2 is B, C, and u1 union u2 is A, B, C, D, E, F. So consider this as small a, this as small b. Jaccard coefficient is a by b, which is length of a by b. 2 by 6, 1 by 3, 0.33. Clear? It is clear, right? Hello. Okay. A graph has 8 nodes and 12 edges. What is the edge density? So edge density is basically how many edges are possible divided by how many edges are there. So a graph having 8 nodes can have how many edges? If you say complete graph, if you make a complete graph, it's like a handshake problem. So one node can be connected to 7 other nodes. The next node can be connected to 6 other nodes, like that. Okay. So just tell me how many edges are possible for a graph having 8 nodes. That is NC2. NC2 is 8C2, which is 8 into 7 by 2. That is 56. 56 again divided by like 2 is to 28. Okay. So answer will be 12 by 28, which is 2 6 are 12, 2 14. That is 3 by 7. 3 by 7 is 7 4s are 28, 0.428. So this will be 3 by 7. Understood? Hello. Hello. Understood, right? Just say yes, no, whatever, like you can actually like there's some like option. Yeah, you can react an emoji like this, something like this. Yeah. So if you want, you can react an emoji. For yes, this. For no, consider it like this. Okay. So if you have any doubts, like how the graph with 8 nodes has 28 edges, it's like a handshake problem. So in a room, consider there are 3 people. How many handshakes will be there? So you shake hand with 2 people, then the second person shakes hand with the remaining person, and the third person shakes hand with you. Okay, so there will be basically 2, 3, 4 handshakes, something like that. So it's like you don't shake hand with the person you have already shaken hand with. Okay, so it's basically NC2. It's not NP2, it's NC2. What is the diameter of a binary tree with 7 nodes arranged in balanced fashion? This is a nice question. I've already explained it, but anyways, I'll go through it, and let me just share my screen again. So a binary tree with 7 nodes looks like this. One, two, three, 4, 5, 6, 7. Okay. Binary tree means each node has 2 siblings. Not more than that, not less than that. Got it? Just say yes, no, or react something. Like I cannot see whatever you are reacting. The screen is completely white here. Okay, so I'm going back to binary tree. I'm going back to, okay, let me go back to binary tree. So a binary tree is a tree. Tree is something like this. It can have multiple children. Each node can have multiple children. Each tree starts with a root node, so this is root node. A binary tree has a special property that each node only has two siblings. Sorry, two children. Not more than that, not less than that. Got it? Cool. So I'm going back. It's very difficult to do this again and again. Okay. Now what comes is, what is the diameter? So diameter is the shortest longest distance between any two nodes. So between 1 and 2 the shortest distance is, no sorry, it should go first. Longest shortest, it should be longest shortest. Between 1 and 2 distance is 1. 1 and 3 distance is 1. 1 and 4 2. 1 and 5 2, like that. 1 2 1 2. Okay. Now distance between 2 and 4 is 1. 3 and 6 is 1. I'm just getting some random one. 2 and 3 is 2. 2 and 7 is 3. 4 and 7 is 4. So what is, like, you will only get these values 1, 2, 3 and 4, not more than that. So what is the highest value here? It is 4. So diameter is the longest possible values of all the shortest distances between any two nodes. So the answer will be 4. Got it? Got it, right? Just like you can react emojis. If you cool. Okay, so yeah, that's all about the diameter. In Twitter follower network, which centrality represents a user followed by other popular users? So it's either say PageRank or eigenvector centrality. So because PageRank and eigenvector, these only tell like if a page is being followed by other people or not, like that. So basically your popularity is influenced by a popular person following you. For example, if Virat Kohli follows you, that's a very big thing for you, because when people will see his following list, because he follows only very few people. For like 287 million Instagram followers, I'm talking about Instagram, he has just 281 following people. So it's like 287 million people have a chance of looking at you, and if like 2 million follow you, that's a very big number, giving like beginner's advantage or something like that. So yeah, that's counted as PageRank or eigenvector centrality. What is the clustering coefficient of a node connected to 3 others who are mutually connected? First of all, it will be 1. So it looks something like this. Let me share it again. So 3 nodes which are connected, there's 4th node, it is connected to all the nodes. Okay, so it's clustering coefficient, obviously if it's local clustering coefficient, it's basically the neighbors. So the neighbors of this node are these, like, sorry, let me draw it. So local clustering coefficient is basically the out degree of that node divided by what we call the complete graphs, the cycles made by its neighbors. So its neighbors are these 3 only, and the cycles made by are these. So it's like how many neighbors are making cycles. So it's 3 by 3. Out degree is 3 by 3 is 1. Okay. Any doubts in this? Had it been something, it should be opposite type. No, it's fine. If it's just connected to 2 nodes, then it won't be there. Yeah. A directed graph has 6 nodes. If the in degree and out degree of each node is 3, what is the total number of directed edges? So like number of edges is equal to in degree and out degree equally, because the in degree and out degree of a graph should be same. Okay, so if it has 6 nodes and 3 edges each, there will be 18 edges overall, which will be like in degree and out degree both. So the answer is 18. Any doubts till now? Just let me know if you have any doubts. Hello, am I audible? Okay. So this is how like we have done week 2. Week 3 deadline, let's see how is the deadline. It should not be over today. If it's over, we can discuss. Yeah, it's over. Anyways, we'll discuss it next session. Let's discuss previous years of week 2. Let's go to 2022. Let's open week 2 and let's solve it. Nice. The questions in earlier assignments were quite tough comparatively. Okay, so I want you people to basically answer the questions, okay? One by one, if you want. If you don't want, like you're willing to refuse, like you have the right to refuse, no problem with that. First one, for a directed graph, if in degree and out degree are these, what is the number of edges? So obviously, in degree and out degree, both is like the sum of in degree and sum of out degree, both is equal to number of edges. So you can take either of those. So there is no option which just takes either of those. See, it's summing it, it's multiplying it, it's adding it, and it's just taking in degree, but it's dividing by 2. That's not good. So this one is summing it and then dividing by 2. So this one should be the correct answer. Okay. Then questions 2 to 8. What are the degrees of nodes 1, 3, 5, 7? I think it's pretty easy. The 1 is 2, 3 is 5, 5 is 3, and 7 is 1. What is the diameter of the network? So let me just draw this network first and then I'll explain. Well, like you can just literally see it here. The longest path between any two nodes, the longest shortest path between 1 and 6 is 1, 2, 3. Like there's nothing shorter possible than this, okay? Between 7 and 6 is 1, 2, 3. Between 4 and 6 is 1, 2. Between 2 and 6 is 1, 2, 3. Okay. Between any of the nodes, the largest possible value is 3. Okay, it cannot be more than that. Yeah, so that will be the diameter. Density again, the total number of possible edges by total number of edges. How many edges are there? 1, 2, 3, 4, 5, 6, 7, 8. And there are 8 nodes, no 7 nodes. So 7 6 are 42 by 2, 21. So 8 by 21. 8 by 21 should be 0.38095 blah blah blah. So the answer is this one, 0.38. Got it? Any doubts? Any doubts, guys? Hello. Okay. Local clustering coefficient of node 3. Node 3 has neighbors 1, 2, 4, 5 direct neighbors. And how many of like 1, 2 and 4 and 5, and how many of them are for making any cycle? There are no cycles per se. Okay. First of all, let me know like if you have any doubts till now. Then I will go to the next question. Okay, let's go to the next question. So the total number of okay, so okay, it has cycle. How it has cycle? It doesn't have any cycle because you remove these edges. If you're considering node 3 now, you have to remove these edges. Then it has just like 1, 2, 4, 5. Node 3 has 1, 2, 3, 4. Oh, sorry, this one. Yeah, it has. Sorry. Node 3 has 5 neighbors. 1, 2, 4, 5, 7. Okay, and it has basically two pairs of cycles. So it will be 2 by 5, I think. No, it won't be 2 by 5. What is the formula of local clustering coefficient? Let me check. Local clustering coefficient formula. Number of triangles connected to node divided by degree of node. That's right. Let me show you this example. For example, let me show you this one. No, don't open YouTube. See, so it has these many nodes and only this one forms a cycle. No, this one even doesn't form a cycle. You have to basically remove that node and then see cycles. Okay. Yeah, see this one. Okay. So this has two nodes, its neighbors, and it's forming a cycle. Okay. Now see this one. Wait, let me go to something. Two times to compute, we use the number of triangles. How many triangles are there? Divided by degree of node into degree of node minus 1. Okay, got it. Now it's correct. Okay, let me share my screen. So basically out of 5 neighbors, only these two are like cycles, so connected to node 3. Okay, so these two are cycles, so 2 by 5 into 4, that is 2 by 20, that is 1 by 10, that is 0.1. Is it correct? Yes. Any doubts? Ayakutti, you said na there is a cycle. Can you like show me what did you think of while saying that? I mean, I didn't get your point. Hello? Sorry? Your voice is very low. No, it's not a cycle. See, let me just explain again, okay? It should be the number of triangles connected to the node, okay? The triangle, proper triangle. Okay, so if you see, let me just share my screen again. I don't have the slides with me. Just a second. I will try to see the video, okay? The thing with this is, just a second, let me check. The thing with this is the definition of cycle is very confusing. Okay, so when you say uh, the degree, first of all, the degree of this node is 5. Okay, and sorry, yes. Okay, now you have to basically find out how many cycles are there. So if you remove this node, if you basically you remove this node, you have to remove it when computing local clustering coefficient. These edges also get pruned. So basically this is not a cycle. So this is what I felt like. So if, yeah, so that's what I was confused about, but it's saying Wikipedia is, I'm considering that definition of Wikipedia, but just let me check, just let me cross check. Yeah, this is the correct formula. See, hello. That's what I was saying. See, number of edges between neighbors of Vi. So number of edges are just the edges are between 1 and 2 and 4 and 5. Correct? So there are 2 edges divided by number of possible edges between the neighbors. So that is basically if we take the node 1, 2, 4, 5 and 7. So basically this is number of possible edges is basically, again the formula is the same. What we call that? 2 into basically what we the handshake problem I said, no? The number of possible edges is 5 into 4 by 2. So this goes up 4 by 20. It's 2 by 10. It should be 0.2, I think. iPad screen. Oh, sorry. So that. Just a second. Let me share. So whatever formula they were given, like it was more or less correct. But let me just show you. So see, the number of possible edges between the neighbors is this one edge, this one edge. Okay. So there are just 2 edges, and total number of neighbors are 5. Okay. So number of possible edges between these neighbors is 5 into 4 by 2. Sorry. 5 to 6 is not, like 6 is not neighbor of that, no? 6 is not neighbor of 3. If had this been joint, then it would be possible, but this is not joint. So this is 4 and 5 both are neighbors of 3. 6 is not a neighbor of 3. 7 is a neighbor of 3. But 7 is not connected to any other node, so we are not counting its edge. Okay. So what we basically do is, there are 10 possible edges between these 4 nodes. 1, 2, 4, 5, 7. And that answer should be 2 by 10. Okay, so it should be 0.2. It should not be 0.1. As it's given here, should be 0.2. Okay, got it? Anyways, just let me, I can try one more thing. uh, just a second, let me ask ChatGPT. Yeah, answer is 0.2 only. ChatGPT is also giving the same answer. Okay, so this should not be the answer, this should be the answer. Okay, the measure of degree centrality for nodes 1, 3, 5, 7. So basically, what is degree centrality? Can you tell me what is degree centrality? Hello? Okay, let me explain. So node 1 has degree 2, it has degree 2. This should be divided by some number. Okay, so that number is basically, I think that number should be total number of nodes, something like that. Okay, let me just check. So for node 0, sorry, node 1, 2 by total number of nodes is 6, 2 by 5. Okay, here the total number of nodes are 1, 2, 3, 4, 5, 6, 7. That should be 2 by 6. Again, the answer is wrong, I think. Okay, let's consider for node 3. Node 3 is 5 by 6. It's not correct. 2 by 5 is 0.4. It should be, this is again, like, I think the answers are marked wrong. Degree centrality of node 1, 3, 5 and 7. So basically, degree centrality formula is the total degree of that node divided by total number of nodes minus 1. Okay, hello? Yeah, the answer is wrong here. Okay, so coming to these questions, I think this whole answer is wrong. This is like 2022, I think. This might have been raised by people at that time, I was not there. Closeness centrality for nodes 3 and 6. Nodes 3 and 6 closeness centrality. So I think it's some closest centrality is related to diameter or something. So like the big diameter and how close it is to shortest path or something like that. Let's just check. Yeah, closeness centrality is basically the shortest possible summation of shortest possible paths between all nodes. Okay, so for node, let me just explain here. For node 3, the shortest possible path from 3 to 1 is 1, 3 to 2 is 1. Similarly, for 3 to 6 it's 2, for other nodes it's 1. So total value will be 7 here. Okay, the total number of nodes apart from it is 6, so that will be n minus 1 by 7 is 6 by 7 is 0.85 something. Okay, for node 6 we do. For node 6, are people there? Yes, okay. For node 6, 6 to 5, 6 to 3, 6 to 4, 6 to 2, 6 to 1, 6 to 7. You do all this, you will get total equals to 14. Then you will have 6 by 14, that will be 0.42 something. So this will be the answer. This is correct. So this was wrong, this was wrong. Okay. Which pairs of nodes out of 2, 4, 6 are closer to each other according to Jaccard similarity? So basically found Jaccard similarity of node 2, 3, 3, 6, 2, 6 and see which one is highest, and you will get 3, 6 as highest, and that will be the answer. Okay. Now, so basically if you are a spy in terrorist organization, sorry about that, it happens because of poor internet sometimes. Okay, so if you're a spy in a terrorist organization with extensive knowledge of social network, which centrality measure will you choose in following situations? To find person who deals with most number of people, that is obviously degree centrality, it will be connected to most number of people. To find boss, boss is connected to influential people of the cartel. Okay, so influential people connected to influential, boss is not connected to everyone, it's just connected to highly ranked people, so it should be eigenvector centrality. The person who can spread message faster is closeness centrality. It is closest to every node in the network. It is basically like closest to the farthest node. Okay, so if I take diameter problem here, the diameter between 1 and 6 is 3. So this node can never be like the highest closeness centrality, because it is like outside the network. It is not closest to 6, it has diameter 3. The closest node to the network is 3 here, although it has highest degree, but see, it can reach all the nodes in just one hop, and the only left node is 6, which it can reach in 2 hops. Okay, so yeah, that's that. So it will be closeness centrality. The person who can spread message faster that is between the centrality. Between the centrality acts as a bridge. Okay, so faster, sorry, the to the farthest points, possible points. Farthest possible points, it's always between the centrality, because the node which is in between, like it acts as a bridge between the graph. Okay, so it can reach all possible nodes. If it's like, if you remove that node which has highest between the centrality, it will break the graph. So the bias does not spread to the farthest possible point. So in order to like break some spy organization, the flow of message in spy organization, what you have to do, just break the node which has highest between the centrality, so the message does not reach the groups, divide into two parts, and message does not reach to the farthest point. Okay, so that is all about week 2, 2022. Any doubts till now? Venkat, do you have any doubts? Hi Venkat, hello. Okay, so I will just keep it short. Let's see how much 23 questions are there. They are more or less same, but let me just go through them. Yeah, so this is similar to the question we solved. 2e by n, that is 2n minus 2 by 2 by n is equal to 1.75. You will get 8. So the answer of this question was supposed to be 8, not that one. Okay, the average degree of a circular node is average degree is basically 2n by n, and for circle the like 2e by n is the average degree, but in circular graph e is equal to n, so the answer is always 2. We have also solved that. Card centrality can be generalization of eigenvector with path attenuation. Okay. Yeah, so let's solve other questions next week. Okay, we are taking it slow so that it doesn't like burden you. We will solve next questions next week, and more of them. We also solve week 3. So the idea is, generally what I do is we solve the current year's latest assignment and previous year's latest assignment. So we will also try to solve week 3 of previous year, week 2 of previous year, remaining previous years, and week 3 of this year. Okay, so we will solve them next week. Do you have any doubts till now? You want to discuss? Just let me know. Venkat, if you have any doubts? Okay. Some new person joined. Ritika, do you have any doubts? Okay, so what we do, that you joined an hour late, so it will be difficult for me to cover what we discussed in an hour. But what we are trying to do is we are trying to solve the assignments, these assignments which are given to you. For the assignments whose deadlines are over, we are trying to solve them. So I just solved week 2 assignment of this year and a few assignment of week 2 of previous year. Next week we will be solving the assignments of week 2 of previous year, sorry, week 3 of this year and week 3 of previous year, and remaining like 2023-24 of previous year, week 2 as well. So we'll be solving around 7 to 8 assignments next week, Friday. I'm not doing it today because it's 15th of August, it's holiday and people are mostly on leave, so the attendance is quite low. But next week we'll be solving them. And then we also, like, hopefully we'll also have a lot more doubts from people who have done the assignments, and they might face a few queries. Okay, so if you have any particular doubts, Ritika, you can ask me. I'll solve it in any other assignment, any part of the course. Hello, Ritika. Sorry. Okay. Anyways, let's do them tomorrow. Okay. Sorry, not tomorrow. Next week, and then let's see how it pans out with all of the remaining thing. Till then, chalo, bye bye. See you. Have a happy weekend. Enjoy Independence Day or like the evening of Independence Day. If you are in Delhi, you can visit. Yeah, happy Janmashtami as well. You can, if you are in Delhi, you can go to India Gate. It's like really nice these days, the weather and everything. But anyways, if you're not there, you can just go around in your cities and colleges wherever you are. Chalo then, till then, bye bye. Let's meet next week. Okay.